Dimension of angular acceleration. We have to find the dimension of angular acceleration. For that, we have to compare tangential acceleration, that is linear acceleration, and angular acceleration. Angular acceleration. To find the dimension of angular acceleration, we have to compare between tangential acceleration and angular acceleration. This is a circular orbit existing in horizontal plane. R is the radius. R is the radius of the circular orbit. O is the center of this circular orbit, and we have a body. This is a body of mass m at the point A. A is the initial point, and the body revolves anti-clockwise in this circular orbit. The body was at the point A at instant t equals 0. At the point A, initial velocity was omega 1, initial angular velocity was omega 1. At the point A, initial tangential velocity was u, and the body revolves and reaches to the point B. The body comes at this point B. This is a point B, and the body reaches to the point B at instant t equal t second. At the point B, the body has the tangential velocity v. V is the final tangential velocity at the point B, and omega 2 is acting vertically upwards, and omega 2 is the final angular velocity, and alpha is the angular acceleration. Along this tangential acceleration A will be acting. A body revolves anticlockwise. A body revolves in a circular orbit of radius r anticlockwise. A body revolves in a circular orbit of radius r anticlockwise, and the orbit exists in horizontal plane. The body revolves anticlockwise, and the body reaches from the point A to B in time t second. In that case, angular displacement will be theta. Theta is the angular displacement of the body. Here we can write theta is the angular displacement of the body in time t second. Theta is the angular displacement of the body when the body moves from A to B in time t second. When the body moves from the point A to B along the circular orbit in time t second. Left hand side we can write L is equal S. L is the length of the arc AB, and S is the linear distance traveled by the body when the body moves from A to B. L is equal to S, which is the length of the arc AB, and that is also the linear displacement traveled by the body when it travels from A to B in the circular orbit. L is equal to S, which is the length of the arc AB, or the linear distance or displacement of the body along the circular orbit when it travels from the point A to B. L is equal to S, which is the length of arc AB, or the distance or linear distance traveled by the body. L is equal to S, which is the length of the arc AB, or distance or linear distance traveled by the body in time t second in linear motion. And also, u is the initial velocity. U is the initial velocity or initial tangential velocity of the body at the point A at instant t equal 0 second. U is the initial velocity of the body at the point A at instant t equal 0 second. Similarly, V is the final tangential velocity of the body. Final velocity or final tangential velocity of the body, or final linear velocity of the body at the point B at instant t equal t second. U and B both are linear velocities or tangential velocities at the initial point A and final point B. Omega 1 is the initial angular velocity. Omega 1 is the initial angular velocity of the body revolving in circular orbit, and this initial angular velocity omega will be acting vertically upwards. Omega 1 is the initial angular velocity. Omega 1 is the initial angular velocity of the body at instant t equal 0 second. At instant t equal 0 second, that is at instant t equal 0 second, at instant t is equal to 0 second, or t is equal 0 second instant. And omega 2 is the final angular velocity of the body at the point B. Omega 2 is the final angular velocity of the body at the point B, that is at the instant t equal t second. Omega 2 is the final angular velocity of the body at the point B, that is at instant t equal t second. Omega 1 and omega 2 are the initial and final angular velocities of the body at the point A and at the point B. The body revolves anti-clockwise in this horizontal circular orbit, and at the point A, omega 1 is the initial angular velocity at instant t equals 0. When the body is at the point B, angular velocity will be omega 2, which will be acting vertically upwards with respect to horizontal circular orbit. And omega 2 is the final angular velocity of the body revolving anti-clockwise in horizontal circular orbit. Alpha is the angular acceleration which is acting again vertically upwards. Alpha is the angular acceleration which acts vertically upwards with respect to horizontal circular orbit. Now A is the tangential acceleration of the body at the point B at instant t equal t second. Here tangential acceleration or linear acceleration A is equal to change in velocity, that is v minus u divided by time t. A is equal to v minus u divided by t, which is the linear acceleration or tangential acceleration of the body at the point B. And that is constant. In this case we have to assume that tangential acceleration of the body revolving in circular orbit remains constant, and alpha is the angular acceleration which is change in angular velocity, that is omega 2 minus omega 1 divided by time t. Alpha is equal to omega 2 minus omega 1 divided by t, where omega 2 minus omega 1 is change in angular velocity. Alpha is equal to omega 2 minus omega 1 divided by t, which is the angular acceleration of the body revolving in circular orbit anti-clockwise. And here A is equal to alpha into r, that's why vector A is equal to vector alpha cross vector r. That is tangential acceleration vector is the cross product of angular acceleration vector and radius vector. Therefore we can say that tangential acceleration is equal to angular acceleration into radius of the circular orbit. Tangential acceleration is equal to angular acceleration into radius of the circular orbit. Now unit of tangential acceleration A, that is unit of tangential acceleration A is meter per second square. On the right hand side, unit of alpha or unit of angular acceleration under bracket alpha, unit of angular acceleration under bracket alpha will be radian per second square. Unit of angular acceleration alpha is radian per second square. Now we have to find the dimension of A and alpha. Dimension of tangential acceleration A is equal to L t to the power minus 2. And on the right hand side, dimension of angular acceleration alpha is can be derived. Dimension of alpha is equal to dimension of omega 2 minus omega 1. Dimension of change in angular velocity, that is dimension of omega 2 minus omega 1 divided by dimension of t or time, and that will be t to the power minus 1, dimension of t to the power minus 1 divided by dimension of t to the power minus 1 divided by t. Therefore, we get the dimension of alpha or dimension of angular acceleration will be equal to t to the power minus 2. Dimension of alpha is equal to dimension of t to the power minus 2. In this way, we can find the dimension of angular acceleration alpha. Dimension of alpha is equal to dimension of t to the power minus 2. This is the dimensional formula of angular acceleration. This is the dimensional formula of angular acceleration. Dimension of alpha is equal to t to the power minus 2, which is the dimensional formula of angular acceleration. Dimensional formula of angular acceleration.